He explains exactly how he built it, all the angles of incidence, all the pressure systems that he used. All of that is so it can be a repeated experiment. But they've ignored this. This is in the beginning of my book. You go to my book, that's the first page on there. Before you even open it up, I've got this, and we rebuilt the Milky Way galaxy the same way, and it predicts the star arrangement better than NASA does. And this is without dark matter. This is without dark energy. This is without the standard model. So
is dark matter or dark energy, are they primarily theoretical?
That's all theoretical. They've never witnessed it, and we couldn't prove that Michelson-Morley experiment that they did in 1887, which said that there was no effect because they tried to move a table around and change the angle of incidence for light to see if the light changed when you move the table. The experiment is like this. The mental experiment is like this. If you're going to experiment, you have an A structure, and you have an idea of how A behaves, and you have a thought that if you put A in a particular situation, it's going to turn into B. So let's picture it hypothetically like you have a bar that's maybe 6 inches long of iron, and you say, okay, well, I think if it goes into the freezer that it's going to get shorter. So you're supposed to have 2 exact bars 6 inches out and leave one outside of the freezer, and put one in the freezer, and then you compare them after you see it. So A over X is equal to R times B over X. R is the result or the change between them. B is the change that occurs. R is what fraction or the X that you use in order to get back to A or to convert it to B. What they did with the Michelson-Morley experiment, because they could not get out of the ether. They couldn't step outside of the ether because it's everything around us. So they couldn't tell a difference, whether they saw no result, no change. So they assumed there was a void, that there was no ether there. And that's when particle physics took off. Lorentz, a great physicist that everybody loved, entered a paper in 1904 where he was continually explaining the ether the same way that Maxwell, all of his theories came off of there being an ether, but he was still limited by Newtonian laws and the Coulomb force of opposites attracting. When it's the positive, it's the things that are alike that attract. But he believed that the ether was still and space was flat. And so space-time, or Einstein relativity, came as a result of them taking the ether away. And for 100 years, we've walked down this particle physics world that's all theoretical. And here I've patented these wave conjugations that is the ether, is the contraction of the ether and the expansion of it. And on top of that, the proof of it was I've been able to build new industries from it. If you go to, I want to introduce the linchpin, if I can. With all of the talk.
Before we do that, can you tell me how a planet is formed under this theory? So you have a sun, and how does the sun give birth to these planets?
The same way we defecate and have gas, like Jupiter's, that red spot on Jupiter, that's spinning on it, that's going to become a moon. It may take a billion or 2 billion years. That will ultimately become a moon off of Jupiter. Where is it? Right at the equator. Where do we discharge at? Right at our equator. And then it will rotate its way around and slowly be pushed out by the solar wind by Jupiter.
So like coronal mass ejections.
Coronal mass ejections.
So some kind of ejection of matter leaves the sun, and over billions and billions of years, enough of it collects, and there's enough of a force
to where ultimately that coalescing idea that they have, that's where it happens. It's not from materials that's just been left over from the Big Bang.